Hi everyone, it is time for your 306 daily help. So let's get a move on and see how we can do with this. All right, so our first problem, let me move myself out of the way and get my pen. Okay, how can triangle WXY be mapped to triangle MNQ? Translate vertex W to vertex M and then reflect across the line containing blank. So we have to decide how we can map it onto this other triangle. All right, first of all, let's go in here and let's label our triangles, okay? They are labeled, I can obviously see that, but let's name this our first one and we're mapping it onto this one. So our first one is, this is our first one, and this is our second one. Okay, so obviously when I made my little triangle down here, I did the wrong thing. I have it going the wrong direction. So let me see if I can turn that around. Okay. I want it to look similar to this number one up here, okay? Similar, that's close enough. All right. So it tells us that we can translate vertex W to vertex M. Okay, so we have vertex W. Okay, let me put a little something on that vertex right here. Okay, that's my vertex W. I want to translate that to vertex M. Okay, so I'm going to grab my triangle. Oh, I put the dot on the wrong one. Guess I can't do that. All right, so we're going to take W and we're going to translate it to vertex M. Okay, and then it wants to know, then reflect across a line containing what? Okay, obviously we can see this now, right? Righto, everybody? That doesn't sit very well. But we see that the line of MN, if we were to flip across that, reflect across that, then this point up here would be our Q point. It would fall onto Q. Y would fall onto Q when we flip it, right? Let me move this back. Okay. So MN, or let's see, WX would be the line we want to flip it over. Okay. WX is the green, what we actually moved. Okay. If we took this and took it back up here, all right, it was WX would be this base. Okay, and we move the W to the M, so that would be our WX is the line we'll move it across. I'll have to keep this in mind next time. This wasn't exactly the perfect way to try to do this, and I'll try to do better next time. Okay, I have another one on the next slide. Let's see if it'll do any better. Okay. All right, the next one says two rigid transformations. That means we're not changing the shape or the size because it's rigid, are used to map triangle HJK. All right, that's going to be our first triangle, to triangle LMN, which is the second triangle. The first is a translation of vertex H to vertex L. All right, so basically we are taking, here's vertex H, and we're moving it up here to vertex L, okay? And then it wants to know what other movement we need to make. What is the second transformation? A reflection across the line containing HK, a rotation about point H, a reflection across a line containing HJ, or a rotation about point K. All right, so let's stop and think about this just a moment. we're trying to figure out what's the best way to move this. We have translated from point H to point L, okay? And then it gives us two different reflections. We can reflect either this side or this side, but a reflection over either one of those is not going to take us exactly over that, is it? It's going to take one of the rotations, and the rotation would be to where we already have this vertex where we've moved from H to L. Now, if we simply rotate around H, that's going to take us onto LMN, okay? If you need to, guys, if you're still just not doing well with this, cut you out a triangle, okay? Then trace it twice on your paper, and then move it and see how it moves, okay? That might be helpful. All right, so this one says if Vx equals Wz equals 40 centimeters and the measure of angle ZWX is equal to the measure of XWZ, which is equal to 22 degrees, can triangle WZX and triangle WXZ be proven congruent by side angle side? Why or why not? Okay, now remember with side angle side, there's got to be two congruent sides and an included congruent angle. So let's label what we do know. Vx is congruent to Wz. So Vx is along this line, and we're going to put that that's congruent to WZ, and that is this line. Okay, those two are congruent to each other, all right? And they are also equal to 40 centimeters. Okay, so 40 and 40. Okay. The measure of ZVX, so the vertex is V, ZVX. So here's that vertex, ZVX is congruent to the measure of XWZ, and they are both 22 degrees. All right. Do we have side angle side? Okay. With this triangle, do we have side angle side? All right. If we look carefully, we have no indication whatsoever. Let's see. Do we have any kind of indication that XW and ZV are congruent? No. Although the endpoints would make them congruent, but we are talking the only thing that we can say is congruent is this line here because they share this line down here. Okay, but that still leaves us one open side. Okay, and to prove side angle side, we need that other side. Let me highlight it in red. Okay, because the angle is here, then we need this other side, and there's nothing that we have that proves. Let's see. Let's look at our answer choices. Yes, along with the given information, ZX is congruent to ZX by the reflexive property, but that doesn't satisfy side angle side. The triangles are both obtuse, but that doesn't answer. I would say not enough information. Not enough information. Whoop. Whoops, I lost my share. There we go. There's share back. All right, so moving right along, and we have a proof. Remember, let's keep in mind always that proofs are something that we can't just have a unit that says, boom, this is how you do proofs. We have to learn to have our toolbox for proofs, okay? Each proof is different, all right? It comes by practice of doing them over and over and getting familiar and getting comfortable with doing proofs. Okay, the proof that triangle EFG is congruent to triangle JHG. So the one on the left and the one on the right is shown. The given G is the midpoint of HF, EF is parallel to HJ, and EF is congruent to HJ. Prove that triangle EFG is congruent to triangle JHG. All right, so we start off with our given that G is the midpoint, okay? And then FG is congruent to HG. All right, that is not part of our given. That is the definition of midpoint. So let's go down here and let's identify FG is congruent to HG. Now they told us that G is the midpoint of FH. All right, so that's what we gain from that. It tells us that EF is parallel to HJ. EF, let's put our parallel signs in HJ. All right, so that tells us something special about FH and EJ. Those are transversals, correct? So that may come into play. All right, so the next one we have a missing congruency, but the reason is alternate interior angles are congruent. All right, and we're trying to figure out just what congruency statement would be correct. All right, if we have EF and, sorry, didn't mean to write that. We have EF and HJ as parallel lines, okay? Then that tells us that FH could be a transversal. And that would mean that the alternate interior angles are here, and they would be congruent. Well, that would be angle FHJ or JHF is congruent to EFG or GFE. Let's see if we have either of those. I put 3 instead of E. That was kind of goofy. All right. Okay, here is, we need EFG or GFE. Here's GFE. And then we have JHF or FHJ. All right, so that one does not match up, does it? Nope. All right. So what about if we look going the other direction? Okay, what do I mean by that? Well, that's not the only transversal that we have. We also have a transversal here and here with alternate interior angles. EJ could be a transversal, and that would be FEG or GEF and HJG and G, J, H. So let's look for the vertex of E and J. Here's E and J. That's the only one with E and J. So let's see. F, E, G, H, J, G. Here we go. All right. So we're calling these our two alternate interior angles are congruent. Okay. And then we have our given of EF is congruent to HJ. All right. So let's put some congruency lines here. Okay, that's our given. And then triangle EFG is congruent to triangle JHG by SAS. Let's look at SAS. All right, here's a side and a side. Here's an angle and our angle, and then the last side and side. So there's where we get our side, angle, side. Don't give up, guys. When you look at, we had 4 different ways to look at these alternate interior angles. We had 2 different sets, and those 2 different sets could be labeled one of 2 ways. Okay? So you had to try all of them to find what worked. Okay? It could have even been this combination instead of this combination. Okay? Always take the time to look through all of it. All right, last one. The proof that triangle MNS is congruent to triangle QNS is shown. Given that triangle MNQ, that is this triangle right here, okay, is isosceles with base MQ. Okay, if the base is MQ, then these 2 sides are congruent, right? If it's isosceles, yep. NR and MQ bisect each other at S. Okay, that's these 2 lines that go up and down and side to side. They intersect, they bisect each other. All right, so that means this and this are congruent, and this are congruent. So prove that triangle MNS is congruent to triangle QNS. We know that triangle MNQ is isosceles with base MQ. So MN is congruent to QN. That's what we did right here by the definition of the isosceles triangle. The base angles of the isosceles triangle at NMS here and NQS here are congruent by the isosceles triangle theorem. It is also given that NR and MQ bisect each other at S. Segments blank are therefore congruent by the definition of bisector. All right, so which segments are congruent by the definition of bisector? Okay, our first set were NS and SR. Our second set was QS and SM. Now they could be turned around, okay? NS and SR. Okay, here's NS and RS. NS and RS. Okay. All right, those are appropriate. Let's see if the QS and SM, actually there's more than one. I'm looking to see if there's something else that we need to prove here. It looks to me like NS and RS are congruent, and it looks that MS and QS are also congruent. that either one of these would be true. Let's see which one is actually the correct answer. They said the last one, even though I fully believe that first one would be too, but let's stick with the last one since that's what they said. I maybe need to put in a correction to Canvas on that one, not Canvas, Ingenuity. All right. Good luck on your quiz, everybody. Oops, I did not mean to move that. There you go. Good luck, everybody.